This is a tutorial on the graphs of functions. A function is a special type of relationship where every x value or every input value has only one y value or one output value. If you have a graph of a relationship and you want to know if this graph represents a function, you can use the vertical line test. Now remember, if x is our input and we have a function, that means we can have only one y value associated with each different x value. Imagine walking down the x-axis. If you can point perpendicular from yourself at more than one location on the graph, then you're not looking at a function. If you can only point to one place, then you are looking at a function. Now, an easy way to determine if the graph of your relationship represents a function is to use the vertical line test. And that basically means that you draw vertical lines through your graph and you see if there is any place that you can put a vertical line where you would intersect the graph in more than one place. Let's look at this first graph. This is a graph of a parabola. If I draw a couple vertical lines, I want to determine if these vertical lines intersect my parabola in more than one place. This one intersects right here, this one right here, our third line intersects right here, and the fourth one right here. None of these lines intersect the parabola in more than one place. And I cannot draw a vertical line that intersects the parabola in more than one place anywhere on this graph. So I would say that this parabola is a function. Now let's look at our next graph. This appears to have an S shape. And if I draw a vertical line like this one, I can see that this vertical line intersects my S shape only one time, and that's right here. But this does not satisfy the vertical line test. The vertical line test asks us, is there anywhere we can draw a vertical line that would intersect our graph more than once? Well, there is. I can draw another vertical line right here, or right here, and I can see that these vertical lines touch the graph in more than one place. This second one intersects the graph right here and right here. My third line intersects the graph in three places, right here, and right here. So just the fact that we can draw these lines, and they're vertical, and they intersect the graph in more than one place, means that this S here is not a function. If I was walking along the x-axis and I got to the origin, I could point to the left and see my graph, and I could also point to the right and see my graph. So this S is not a function because it fails the vertical line test.
Now that we know what the graph of a function looks like, let's see what kind of information we can get from the graph of a function. Here we're given the graph of a parabola. This is a function because it passes the vertical line test. There's nowhere that I can draw a vertical line that would intersect this graph in more than one place. So this parabola does represent a function. Now we're asked for some information about the function shown in this graph. The first question is, what is the function value when x is equal to 0? Remember, function notation is f of x, and then we usually have some equation here. The function value is the y value for this value of x. So if we want the function value when x is equal to 0, then we're really looking for the y value on our graph when x is equal to 0. So to find that, we go to where x is equal to 0, and that's at the origin. and then we trace a vertical line that passes through the origin. Every point on this vertical line has the x value of 0. Now we just need to find the point on this vertical line that has the same y value as our graph, and that's right here. This point on our graph has an x value of 0 and a y value of about negative 2.5. So our function value when x is 0 would be a negative 2.5. Now if we want our function value when x is 1, we go to 1 on the x-axis, and we draw another vertical line passing through that point. This vertical line intersects the graph of our parabola here at the point 1, 0. So our y value here would be 0. So our function value when x is 1 is equal to 0. Now this is the only function value for this x value, and we know that this function value of 0 is the only value to go with this x equaling 1 because it's a function. So our function value must be 0 when x is 1. We're also asked what is the function value when x is equal to negative 2. Well, x is equal to negative 2 is right here. If we draw a vertical line, we can see that the only point on our graph that has an x value of negative 2 is this point right here. This point's y value is negative 4, so our function value when x is equal to negative 2 would be negative 4.
Now let's answer some different questions. Here we're asked, what is the domain of f? And the domain is any x value that I can plug in to this function. Well, this is a parabola. It goes on forever in those directions. And as it gets higher, my x value is going to get either smaller or larger. So I would say the domain of this function is that x can be all real numbers, because there's no x value that I couldn't plug into the equation of a parabola. Now, if you didn't think that this function continued on forever, if you thought it stopped right here and right here, then you could say that x is between 3 and, say, 7, negative 7. So you could say that the domain is between negative 7 and 3 as well. But I would pick the one that's all real numbers, because I know this is a parabola and I'm thinking that this goes on forever. Now we're also asked, what is the range of our function? Now the range is all the y values that we can get. Well, again, this graph appears to go up forever, but since this is a parabola, there is a minimum y value. So our range of f is that our function, f of x, has to be greater than or equal to negative 4. And it's negative 4 because I can see on my graph that the smallest y value I have is negative 4, and all of my y values are larger than that. So if negative 4 is my smallest y value, that means my smallest value of my range is also negative 4. And since values greater than negative 4 are okay, I say that the function has to be greater than or equal to negative 4. We can also use this graph to determine what the intercepts of the graph are. Remember, the intercepts occur when either x or our function value, y, is equal to 0. If we want to know when our function value is equal to 0, when f of x is equal to 0, you have to remember that f of x is equal to y. So we want to know when y is equal to 0. Well, y is equal to 0 when we cross the x-axis. So these are our x-intercepts. And I can see that we're going to cross at negative 5, 0 and at 1, 0. Now we may also look for the y-intercepts. That's when x is equal to 0. So if we want the function value when x is equal to 0, we can find that on our graph too. That would be right about here, because if x is equal to 0, that's the y-axis, and we cross the y-axis at about 2.5. So I would say that our function value at 0 is about 2.5. So those are our x-intercepts. This one is our y-intercept. And we got these by just looking to see where our graph crosses the x and y axis. Let's answer a couple more questions about this graph. Here we want to know what value of x makes our function equal to 1. Well, again, remember that y is equal to f of x. So if f of x is equal to 1, that means y is equal to 1. So if we go to where y is equal to 1, that would be here. And we want to know where on this graph y is equal to 1, that would be right here and right here. So we have two values of x that make y equal to 1. This one here is about 1.5. So x would have to be about 1.5. Or x would have to be about negative 5.5. Approximately. Our next question asks us, what values of x make f of x less than 0? Now remember, f of x is just equal to y. So we want to know what values of x make y less than 0. What values of x make y negative? Well, y is negative when it's below the x-axis. So all of these values on our function all will have a negative function value or have a negative y. They stop here where we cross the x-axis. This point has an x value of 1. So if we're less than that, we should get a negative y value. I also have an x value here of negative 5, and if we're greater than that, again, we should get a negative y value. So our values of x that make our function negative are that x has to be greater than negative 5, but less than positive 1. These values of x should get us a negative y value, and therefore should make our function less than 0. Now usually when we deal with functions, we're not given the graph of a function. We're given the equation of the function, or the function itself. Here we have the function f of x is equal to x squared minus 9 over x plus 4. And there are some things we want to know about the graph of this function, even though we don't have the graph in front of us. For example, we want to know, is the point negative 2, negative 5 halves on the graph of this function? Now to figure this out, you have to remember that y is equal to f of x. This is an xy coordinate. So all you're going to do is take f of x and replace it with negative 5 halves. And then you're going to take x in every place that it appears, and you're going to replace it with negative 2. So if we do this, we'll have negative 5 halves, and that's equal to negative 2 squared, because it's x squared, minus 9 over negative 2 plus 4, because it's x plus 4. Now negative 2 squared is a positive 4, so positive 4 minus 9 is negative 5. Negative 2 plus 4 is a positive 2. So we have negative 5 halves is equal to negative 5 halves, and that makes sense So we would say yes. This point is on the graph of our function. Next we're asked, if x is equal to 1, what is our function value? And then what is this point on the graph? Well, if we know x is equal to 1 and we want to know our function value, we're looking for just f of 1. And to find this, we take this value of 1 because x is equal to 1 and we replace x in our function with the number 1. So we have 1 squared minus 9 over 1 plus 4. 1 squared is 1, subtract 9, that's a negative 8. 1 plus 4 is 5. So our function value, when x is 1, is equal to negative 8/5. What point is this on the graph? Well, remember that f of x is equal to y. And that means y is equal to negative 8/5 when x is 1. So we have the point 1, negative 8/5. What if we were asked the opposite though? What if we were given a function value and asked what value of x gives us this function value? If f of x is equal to 55/12, what is x equal to? And then what is this point on the graph? Well, again, remember that f of x is just equal to y. So I'm going to take this 55/12 and I'm going to replace f of x with 55/12 and solve for x. So 55/12 is equal to x squared minus 9 over x plus 4. Now if I want to solve this, I cross multiply. So we'll have 12 times x squared minus 9 is equal to 55 times x plus 4. If we distribute the 12 inside these parentheses and the 55 inside these parentheses, we'll end up with 12x squared minus 108, and that's equal to 55x plus 220. Now I'm going to move everything to one side of the equation because this is a quadratic. So I'm going to subtract 55x from both sides, and I'm going to subtract 220 from both sides, and we'll get 12x squared minus 55x minus 328 is equal to 0. If we want to solve this quadratic, it's probably easiest to use the quadratic equation, where x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Now our a value here is 12, our b value is a negative 55, and our c value is a negative 328. So we'll get x is equal to negative 55 plus or minus the square root of negative 55 squared minus 4 times a, which is 12, times c, which is a negative 328. And then all over 2 times 12. If we simplify this, we'll get x is equal to a positive 55 plus or minus the square root of 3025, which is 55 squared, plus 15,744, which is 4 times 12 times a negative 328. And then that's all over 24. Now, 3,025 plus 15,744 is 18,769, and if you take the square root of that in your calculator, this will come out to 137. So we have x is equal to 55 plus or minus 137 over 24. Plug all of this into your calculator, and you'll get x is equal to 8, or x is equal to negative 3.42, approximately. So those are our x values. And the points that go with these x values, well, our y value is always 55 over 12, so we would have the point 8, 55 over 12, and then negative 3.42, 55 over 12. What if we wanted to know the x-intercepts of this function? Well, we have to know that the x-intercepts occur when y is equal to 0, or when our function is equal to 0. So all we do is replace f of x with 0. We say 0 is equal to x squared minus 9 over x plus 4. Now this is a fraction, so the only thing that can make this fraction equal to 0 is the numerator, or, if you can't see that, multiply both sides by x minus 4. If you do that, on the right-hand side, the x minus 4's will cancel, and on the left-hand side, we have 0 times x minus 4, and that's still equal to 0. So we end up with x squared minus 9 is equal to 0. I'm going to add 9 to both sides. Get x squared is equal to 9. Take the square root of both sides, and you'll get the absolute value of x is equal to 3, which means x has to be equal to 3, or x has to be equal to negative 3. These are our x-intercepts, because these values of x make y equal to 0. So our x-intercepts are 3 and negative 3. What if we wanted to know the y-intercepts? Well, the y-intercepts occur when x is equal to 0, so we would just plug that in. 0 for x in both of these locations. We would have f of 0, because that's what x is equal to 0 minus 9 over 0 plus 4. So our y-intercept then, or our function value when x is equal to 0, is negative 9/4, which means our y-intercept is at negative 9/4. And that's our y-intercept. So that's how you can use the equation of your function to find several things on the graph of your function. And now that we know how to use the graphs of functions, that completes this tutorial.